So in this video, I'm going to be working on problem 6 from the first test in spring 2020. So what we want to do is we want to obtain a formula for predicting the number of confirmed cases in China from the number of days since January 21st. So we want the code and we want the formula. So, okay. So how can we do it? So the first thing to do is to graph the cases for China. We kind of have already done that, but let's redo it so that it's just China so that we have maybe a slightly better look here. Okay, so here we're filtering so that it's just China. And here you get, well, something like this. So you see actually here that the curve is slightly starting to decrease here, right? So, but certainly if you tried to do just scale y continuous, which is the alternative, what you would see is something that's like also not quite linear. So in order to see better, we should probably also add geom point here just to get an idea of what the points will look like. So this is with y. So this is with y not being displayed on the logarithmic scale, and this is y being displayed on a logarithmic scale. So we don't really have a lot of choices other than doing things on a log scale or doing things on kind of without the log scale. So we could also try to do scale x log 10 and see how that works. Maybe that's going to look more like a straight line. So that actually looks kind of reasonable. So it seems like maybe the best bet is to predict log y using log x. Okay, so, okay, all right. So we can actually check. This is more than was required. So kind of what I'll write for the solutions is I'll write this up. But I'll say kind of you should display kind of first you should display just, you know, this. And you should probably also try to display the y just on a log scale, but the x not being on a log scale. So that's the other possibility. So how do you definitively decide? So one way to try to decide is to just see what is the SSE for all three of those possibilities. And again, this is more than was required of you for the test. Like if you had just said like, you know, I'll do like the y on the log scale, that is fine. So I'll just try to predict using every method. So C1 is my data set, right? So my fit1 is going to be LM, and I'll predict the number of confirmed cases using, so it's just China, so I don't need to worry about much of anything. So it's going to be confirmed based on days since start. So this is just the linear model. Confirmed seems to not have been found. So, oh, because it's called something else. It's like toll. Yeah, toll confirmed. So I'll do it like that. And now actually similarly to, I believe, precept 4, we can compute the SSE for this case, right? So the SSE here is going to be predict fit linear new data is equal to C1. New data is just the old data. And we'll do y minus that. So this would be C1 total confirmed minus predict, like this. All squared, and then, well, let's do the MSE. Let's say, so we'll do like MSE linear, and that's going to be the mean of the squared errors, like this. You could also do the SSE, that's fine too. So that is the mean squared error. So we can also try, so I'll call it like x log y. So the number of confirmed is just still the total number confirmed. It's not the log, but the y we take the log off. So that's going to be like this. So I'm going to say LM total confirmed. That's now log of total confirmed. And that's going to be my fit. So I can now, again, predict fit x log y new data equals C1. So the predictions, didn't run this today. Comma, new data equals to C1. So the predictions are now going to look like this. So the predictions, you know, are log, right? So in order to get back to the total confirmed so that it's comparable here, I'll need to say x of. And now I can say MSE x log y is mean of the total number of confirmed minus this much. And now I need to enclose it in parentheses again, like this. And now I'll square it, and I'll do the mean squared error, right? So by how much am I off? Could have also taken, so let's actually take the square root. So let's call it SMSE for square, RMSE rather. RMSE, and I'll do like square root so that we're nicer. And also I believe we needed that anyway at some point. So RMSE linear here is going to be like this. And RMSE, so we're off on average by like at most twice that is the guideline. So, okay, so RMSE x log y is going to be square root of this. Because so here again, we predicted on new data CY, but we predicted the log of total confirmed. So to get back to total confirmed, we did x of that. So that's going to be like this. And the RMSE turns out to be this much, so 19,000, whereas this was 5,000. So, okay. So next, we'll try to do fit log x log y. Do LM total confirmed. So log of total confirmed. Log of days and start, and data is C1. So I'll just copy this. So it's going to be log x log y. So square root of mean C1 total confirmed. So when you're predicting, you need to do the exp again. So that's actually going to be the same, except I need to say log x log y. And that's going to be the best one. So 3000 is the best one. So log x log y is the way to go. It's this curve. Okay. So we now need to say, okay, what's the formula here? So this is fit log x log y. So the formula is log of this would be confirmed. Do it as a comment. Is equal to 5.4 plus 1.75 times log of days. So that means that if we want to predict confirmed, we would do confirmed, which is cool. So this is the prediction. So confirmed is equal to x of 5.4 plus 1.75 times log of days. That's like that. So you might know, so again, like not really required, but you can in fact go a little bit further. So you can say this is equal to x of 5.4 times x of 1.75 to the power of days. Sorry, the other way, of course. So this 1.75 times log of days, that's equal to log of days to the power of 1.75. Exp of that is just days to the power of 175. So it's going to be exp 75 times days to the power of 175. Okay, so that is the best equation. So this is this. So you did not have to go this far. This kind of thing was pretty reasonable. Okay.